Hello everyone, welcome back to the No Mr. Science channel. Let's go for another solution step by step. Determine the resultant produced by the forces Fb and Fc about point A. Express the resultant as Cartesian vector. So first, we're gonna find our vector AB because we want to transform my force Fb in Cartesian vectors. So my vector AB is 0I plus 2.5j minus 6k. So my vector AB is equal to 2.5j minus 6k. Now we're going to find the magnitude of the vector AB. That's equal to the square root of 2.5 square plus minus 6 square. So the magnitude of my vector AB is equal to 6.5. Now my unit vector AB is equal to 2.5j over 6.5 minus 6k over 6.5. So my unit vector AB is equal to 5j over 13 minus 12k over 13. Now we're going to find the Cartesian vector FB. That's FB times my unit vector AB. So my FB in Cartesian vector is 780 times 5 over 13 j minus 780 times 12 over 13 k. So my vector FB is equal to 300j minus 720k. So we're gonna save this information. Now we're gonna do the same approach, but now for the vector AC. So my vector AC is 2I minus 3j minus 6k. The magnitude of my vector AC is equal to the square root of 2 square plus minus 3 square plus minus 6 square. So the magnitude of the vector AC is equal to 7. Now the unit vector AC is equal to 2I over 7 minus 3j over 7 minus 6k over 7. Now we have conditions to determine the vector FAC in Cartesian vector, or FC in Cartesian vector. So I have the FC times the unit vector AC. So I have the vector FC is 420 times 2 over 7I minus 420 times 3 over 7j minus 420 times 6k over 7. So my vector FC is equal to 120I minus 180j minus 360k. So we're gonna keep this information. Now our third step is find our vector distance of point O. So my vector distance of point O will be the vector AO here. So here I have my vector distance is 6k. So now I have enough conditions to find my moments about point O. First, we're gonna find our moment vector of force B about point O. That's our vector distance, cross product, our force B in Cartesian form. Now I'm gonna put my matrix I, J, K. Here I have 0, 0, 6 because our vector distance, and our vector B that we found in the first slide is 0, 300 minus 720. I, J, 0, 0, 0, 300. Doing my cross product, I'm gonna find that my moment P is equal minus 1800 I Newton meter. Now the next step is find the moment about O that my force C produced. So the cross product of RO and my force C. Again, my matrix I, J, and K. Here my I, J, 0, 0, 6 because the same distance. Now my vector is different. I have 120I minus 180J minus 360K. 120 minus 180. We're gonna have my moment in C is equal 720 J here plus 1080 I newtons meter. So now I have both moments, that moment that force P produced about O and the moment that force C produced about O. Now, to finalize our exercise, we're going to find the resultant moment is equal the sum of moment P plus moment C. So my resultant moment is equal minus 1800 I plus 1080 I plus 720 J. So my moment expressed in Cartesian vector is minus 720 I plus 720 J newtons meter. So we finalize our exercise. Thanks for watching until the end. Don't forget to subscribe, like the video, and share with your friends. Thank you.